Okay, so for question 3, the first question is about formal charge, and it's a case of do you remember how to calculate formal charge or not, which is valence electrons minus the non-bonding electrons subtracting half the bonding electrons in brackets. So formal charge equals, top here, valence electrons minus, in brackets, non-bonding electrons minus half the bonding electrons. And if you remembered this question was easy because your central atom is carbon. Carbon has 4 valence electrons, so you have 4 minus something something. Now the non-bonding electrons are 0 because there are no lone pairs shown on that carbon. I mean, you should know it satisfies the octet rule. It's a small atom, can't break it. Both of them have 4 bonds, which means 8 bonding electrons. Half of 8 is 4, so the formal charge is 4 minus 4. As a result, it's 0 for both of them. Therefore, both structures are allowed by formal charge. That was the answer. Okay. Now, for 2, it was asking you to understand. Remember, it's asking for the HNC bond angle, not the NCN bond angle. The HNC bond angle, because there is a lone pair on the nitrogen, you're expected first to understand that in the case of structure 1, its electrons have a tetrahedral arrangement, but the lone pair repels the other groups closer together, away from the lone pair. So you're going to end up with a bond angle which is less than normal tetrahedral 109.5. Then for structure 2, the electron arrangement is trigonal planar, but because you have a lone pair, not a bonding group on one side of the nitrogen, it will push the C and the H a little bit closer together. Therefore, the bond angle is going to be a little bit less than 120. Okay. Now, for part 3, which structure has all the atoms in the same plane? Well, you have to remember that the structure 1, the electron arrangement of structure 1 for the NH2 group is tetrahedral, so you're going to have hydrogens above and below or outside of the plane of the molecule. Structure 2 has sp2 hybridized nitrogens on both sides, therefore everything's going to be in one plane. 2 trigonal planar groups around a central carbon atom. Okay. Now for B, most of you did that very well, balancing that equation. For C, you need to just plug or turn the grams of calcium cyanamide into a molarity, into moles, etc., etc. So the answer is shown clearly at the back. Calculations is how you can do that. Now for D, I think the process you need to go through is balanced equation of ammonia, which for any base, weak base is here. So NH3 plus H2O goes to NH4 plus OH minus. Then write the equilibrium expression. You ignore the water. So you have NH4 OH minus on the top, NH3 on the bottom. Now because it's a weak base, that means you can ignore the fact that you can ignore the change in concentration of the NH3. So if I write that out, actually, I don't see why not. It's my tissue. So NH4 plus, OH minus at the top, NH3, and you're given a Kb, which is 1.8 times 10 to the minus 5. Now, this is going to simplify down to 2x at the top, so x for NH4 plus, x for OH minus, because the molar ratio is 1 to 1, over 0.833 mole, which is what you worked out in the question before. This one. And then after you solve for that, you will get the concentration of OH minus ions. Now, if you find the POH, you do the negative log of that, then you can use the POH plus pH equals 14 expression given on your formula sheet to work out finally the pH. Okay. Now, E. I talked about ammonia and the Haber process, and I spoke specifically about this example, about how although to make the equilibrium go to the right, you would have low temperatures and high pressures. Because of the kinetic consideration, that reaction happens too slowly because it's low temperatures. You should use high temperatures to favor both the kinetic and the product yield. So you have high pressure to favor the product yield and high temperatures to favor the kinetic yield. Okay.